All right, let's get right into it. Welcome to This Explainer. Today we're breaking down the incredibly complex, completely invisible compounds that literally power our very existence. And to do this, we're actually going to use something you probably have sitting in your refrigerator right now as our foundational guide: milk. It turns out this everyday liquid is an absolute masterpiece of biological engineering, and it holds the answers to how our bodies function on a microscopic level. So let's start with a fundamental question, one that actually puzzled scientists for decades before they finally unlocked the secrets of modern nutrition. I mean, for a long time, we knew bodies needed proteins, we knew about fats, and we knew about carbohydrates. But there was obviously something missing. What were these invisible, organic compounds that don't provide energy themselves and don't build our tissue framework, yet without them, our biological engines completely seize up? The answer, of course, is vitamins. But to really grasp this, we need to understand that these are highly specific chemical cogs in our biological machine. They're governed by a few strict rules. First, they are carbon compounds required in absolutely tiny, minute amounts for us to just function normally. And perhaps the wildest, most defining characteristic, we generally can't synthesize them ourselves. We are completely 100% at the mercy of our diets to get them. Here is our roadmap for today's explainer. We'll start by decoding the vitamin classes, then look at fat-soluble vitamins A and D, move on to fat-soluble E and K, dive into the water-soluble B complex, and finally wrap things up with vitamin C. Okay, moving to section 1, decoding the vitamin classes. So the absolutely crucial point here is that a single physical property, solubility, essentially dictates the entire life cycle of a vitamin in your body. It dictates how we absorb them, how we store them, and how we utilize these two distinct factions. Class A is your fat-soluble vitamins, that's A, D, E, and K, which our bodies can easily squirrel away in fat reserves for later. Class B is the water-soluble crew, the massive B-complex family and vitamin C. Because they're water-soluble, they get flushed out easily and have to be continuously replaced. This brings us back to milk, which brilliantly illustrates how a complex fluid acts as a universal carrier. Because milk is an emulsion, meaning it contains both liquid water and suspended fat globules, it carries notable concentrations of both classes. You have high amounts of fat-soluble vitamin A, clocking in at 1,590 international units per liter, sitting right alongside water-soluble nutrients like vitamin C at 20 milligrams and B12 at 7 micrograms. It's basically nature's ultimate multivitamin delivery system. Section 2. Let's zero in on vitamins A and D, are fat-soluble heavyweights. It is honestly incredible how our bodies act as these highly precise biochemical scissors. Vitamin A, also known as retinol, is formed by the cleavage of provitamin A carotenoids, like beta-carotene, which are made by plants. Now, we can't make beta-carotene ourselves, but when we eat it, our bodies split that polymer perfectly in half to yield two totally usable retinol molecules. This exact chemical conversion is absolutely crucial for the vision process. Lacking it literally leads to night blindness. And because vitamin A is fat-soluble, its concentration is directly tied to the fat content of the food itself. That's why high-fat dairy products like butter and cheddar cheese are incredibly dense reservoirs of vitamin A compared to standard fluid milk. To put it in perspective, butter holds a massive 2,900 international units per 100 grams, simply because all that fat has been concentrated down. Then we have vitamin D, which, interestingly enough, acts almost more like a hormone in our bodies, triggering the synthesis of calcium-binding proteins. What's beautiful here is that both of its primary forms rely on a partnership with ultraviolet radiation from the sun. Plant material uses UV light to convert a compound called ergosterol into vitamin D2. Meanwhile, in animals and humans, UV light converts a precursor right in the skin into vitamin D3. So whether it's happening on a leaf or directly on a cow's back, sunshine is the catalyst. Without this, you're risking severe bone density issues, like rickets. Moving right along to section 3, vitamins E and K are premier antioxidants and clotting agents. The physical structure of alpha-tocopherol, which is the most potent form of vitamin E, features this incredibly long carbon chain. That specific structure is no accident. It allows it to act as a powerful reductant, meaning it serves as a critical, hardworking antioxidant in both milk and in human tissue. By aggressively protecting vulnerable lipids from oxidation, vitamin E serves as our internal biological shield. We generally need about 15 milligrams a day, largely pulled from polyunsaturated vegetable oils, nuts, and seeds. And here's a fantastic little fact. The concentration of vitamin E in cow's milk is highly dependent on the seasons. Because it relies on fresh feed, summer milk actually has a noticeably higher concentration of vitamin E than winter milk. Next up, vitamin K. The defining feature here is the 2-methyl-1,4-naphthoquinone rings in its structure. These specific ring formations are absolute, non-negotiable prerequisites for your blood's ability to clot. If you didn't have this exact chemical geometry floating around in your system, a simple scratch could lead to dangerous, non-stop hemorrhaging. But what's genuinely fascinating about vitamin K is the symbiotic relationship we have with our own microbiome. See, while vitamin K1 comes from plants and makes up our major dietary source, vitamin K2 is completely different. It's synthesized entirely by bacteria already living inside the human gastrointestinal tract. They literally manufacture this vital clotting agent for us. Well, it's more like a biological trait, but they make it right inside our own digestive systems. All right, section 4, diving into the water-soluble side with the B complex. Now, unlike the fat-soluble vitamins we just talked about, these B vitamins are quickly flush right through our water-based systems. They're a heterogeneous, or highly diverse, collection of chemicals, and because they wash out so easily, we have to constantly replenish them through our diet to keep our cellular engines running. They essentially act as the crucial coenzymes for practically all of our energy metabolism. Let's look at how this builds a metabolic pathway, using thiamine, or vitamin B1, as our prime example. Thiamine acts as the critical spark plug. It becomes the coenzyme thiamine pyrophosphate, or TPP. TPP is required to catalyze the conversion of pyruvate to acetyl-CoA, which then directly enters the Krebs cycle to make energy. Without B1, this entire energy-producing assembly line just comes to a grinding halt, which leads to severe nervous system issues, like the disease beriberi. Finally, section 5, vitamin C, and a pretty wild evolutionary twist. Vitamin C, also known as ascorbic acid, is absolutely essential for the formation of collagen. A deficiency here leads to scurvy, which we've all read about in history books. But here is the evolutionary catch. Most animals on Earth synthesize vitamin C perfectly well inside their own bodies. However, primates, which includes us humans, and, oddly enough, guinea pigs, cannot. Why? Because we lack just one single specific enzyme called glucolanolactone oxidase. Because of that one missing biological tool, we are entirely dependent on our diets to supply this vital acid. I really hope this explainer leaves you marveling at the sheer chemical complexity of the food on your table and the brilliant biochemical factory that is your own body. We rely on this incredibly intricate dance of fat-soluble and water-soluble molecules, from retinol all the way to ascorbic acid, just to survive day to day. So the next time you pour a glass of milk, remember the massive, invisible payload of life-sustaining vitamins it's carrying. Thanks so much for joining me, and keep exploring the science hiding in plain sight.